Hi, everybody. Oh, wait, so is it the green button to go next? Okay, all right. Right on. All right. Okay. Hi, everybody. I'm Andrew Starks. This presentation, I want to acknowledge the original author of it and the original presenter, Ben Cope, who is the co-chair of the IPMX Codec activity group, along with Andre Testa of Macnica Video. So all credit to Ben for creating this presentation, and I hope I can do a good job of giving you guys the material he's put together here. In addition to Matrox and also Intel, we have all these companies here on this page that have been participants in the Codec activity group. So it's been a very active group, and we've gotten a lot of great work done together. Macnica, or the company I'm with, has been proud to be a part of that as well. We started this group in VSF, and that wasn't necessarily a trivial decision. So going back before this activity group started, there had been a bunch of conversations, a lot of them kind of circling around in the Ames area about how we're going to decide on this codec issue, right? So at first, we went ahead with JPEG XS, we put it out in the marketplace, we got a lot of market feedback, a lot of people with different opinions about it, and we can sit around and we can talk about this and decide, but we knew we needed to have a process behind it. And Ames is really not set up for that. And VSF really is. And what we wanted to do is we wanted, from the Ames perspective, Ames needed someone to bring them a methodology, a way to look at what it is that was needed in the marketplace, what is out there and available, and a way to evaluate and make the decision. And so I just want to put these three organizations up here. These are really the three core organizations, AMWA, VSF, and Ames, that are part of IPMX, all of them creating IPMX, but it's really Ames and VSF are kind of partnered up on this one. Sam did a great job of talking earlier about the macro trends in the Pro AV industry, but really there's this move, from conversions from AV to IT and AV over IP. There's off-the-shelf hardware is becoming much more, an expectation with this stuff. And, actually, I'm going to a little bit forget what Ben's point here is on this slide. But the idea here is that we want to see, an open standard for AV over IP that meets a wide variety of use cases, not just in the broadcast, but also in all the spaces that we're seeing video and audio in there. And so that takes a lot more than just a single codec. And Sam showed this slide earlier today. And this is a nice little graphic here that kind of highlights how IPMX really is kind of split off into profiles, as we mentioned earlier. And I think you can see on the bottom, there are different kind of major categories of codecs that we're kind of identifying right now. It kind of, you can kind of think of it like uncompressed, and then there's the mezzanine compression or high full bandwidth compression, where you're really trying to replace perfect video, but you need it compressed, so you want super low latency, mild compression. And then you got your limited bandwidth scenarios where you're trying to pack as much information into a pipe as you can, and you're willing to trade a little bit of quality and a little bit of latency to get that done. So really, we're right now focused on kind of those first two compressed use cases, the mezzanine and also the high bandwidth. And there's kind of a third middle in there too, we'll talk about in a minute. But in terms of the group's activity and what our scope is, as Brad mentioned, it is kind of tricky. We don't want to be in VSF making technical judgments about different technologies. We want to evaluate them, and we make the specifications that eventually get turned into standards, but we don't want to be picking winners and losers so much. So really, the group is focused on use cases, determining what the right criteria is for selecting a codec, and also creating a test plan and publishing the results of that test plan. So we're not here to pick the winning codec. We're not actually testing codecs, so we're not going in and actually making new tests and coming up with those results. We're using what's already kind of out in the field. We're also not discussing the cost of codecs or the particular, what the particulars are. We do mark up, like, for example, whether a codec has a RAND fee, but we don't get into the specifics there, and we certainly don't like give a checkbox for one or the other. We just kind of relay the information. And we're not developing new technology. This is really something where we're focused on using what's already out there, and thankfully there's quite a lot out there that we were able to leverage. So Ben had shared this roadmap of deliverables already, and I'll share this here. So we have before, but now it's kind of been updated with our current progress. So we have, we started with use cases. So we built, I don't know how many use cases, but many use cases, that were actually more about IPMX than just about the codecs. But because the codecs play such an important role, it ended up really kind of dominating those use cases. So we started with use cases. We generated a report and kind of using the JTNM process that's already available. And then we have a draft. We now today have a draft of our Codec report, or Codec landscape report that's basically available now. And then we're looking to, in Q1 of 2004, publish that document and make it available to AIMS. So as I mentioned earlier, we're really focused on constant bit rate and variable bit rate, or actually what I said earlier was mezzanine, which is more the constant bit rate side of things, so -22. And then we're now adding variable bit rate for more high efficiency codecs. And so we kind of focused on those two elements of the use case, the original use cases. Now this is, again, an eye chart here, and I won't spend much time on here, but you'll notice there's some blue in there. What we have here these are kind of the lead use cases on the left-hand column, and then the common theme on the right column. And in blue, those are kind of the key use cases that really kind of span all of the little detailed use cases. So if we look in, this is kind of boiling it down to more of a graphic. You have your mezzanine iframe. This is like you're really trying to eke as much quality out of the video as possible. You might be doing switching between sources or switching between content sources. And so you really are trying to keep things as high quality as possible. The mezzanine intraframe is very similar to the mezzanine iframe, but we have this in here. This is where we're talking about, I forget the name of it. It's JPEG XS2. I've heard it called that. I've called it called Flawless. HCJ2K has a similar technology called codec caching. But basically, it's where you have iframe, but you're able to use prior information. So you're able to maintain a subframe latency still, but you're using information from prior frames to gain quality. And this is especially helpful in desktop content. So with desktop content, we're able to see a remarkable improvement in video quality unless you switch or unless there's a lot of motion. And then there's a slight drop in video quality. So it's a bit of a trade-off, but it's very helpful for things like spreadsheets and lots of very detailed content when you're trying to squeeze 4K video into a 1 gig connection. So that's where mezzanine iframe kind of comes in. And then, of course, the high compression, right? So that's where, PTZ cameras and you're trying to fit multiple flows over a network. Next few slides here, I'm going to just kind of touch on the different decision factors that we landed on. Of course, visual quality, using both objective and subjective methods. This is a really tough one, right? There's no, mathematical answer that's going to work for every bit of content, but visual quality, of course, is a key one. And glass-to-glass latency is another one. So even in the Pro AV industry, subframe latency is a huge thing. So if you're a product that can support that, you're in one class of products, and if you can't, you're in another. Even though, for a lot of use cases, subframe latency might not really be required, in the Pro AV industry, it's pretty critical. So latency is right up there with quality in terms of importance. Switching latency, clean switching, right? So if I have a codec that's long GOP, that's not really going to be possible, or it'll be more limited. Even with a mezzanine iframe, where you've got where you have prior frame information as part of it. There's a little bit of dip in quality when you switch sources. So looking at that kind of thing is important as well. And then, of course, some codecs don't support every pixel format or color space. That's not that common, but it is important. Alpha channel support is also part of the picture, so we at least include that. And then other things like bitrate range, bitrate control, the complexity, that's a key one. Even getting into, it's a little bit difficult, right? Because some implementations are maybe more advanced than others or emphasize different things. So it's difficult to look at someone's implementation, even if they would tell you what the complexity is of it. You really have to look at the codec and how it's designed and that sort of thing. But all of that software story that's part of IPMX is really critical. So that's why we make it as part of the decision factors. Complexity. Go ahead, Brad.
Actually, I had a question if you could go back a slide.
How do I go back? This button?
Yeah. There you go. So on the software IP complexity, I was just curious, was there any look at how the costs were loaded between encoding and decoding? Some compression algorithms are very costly to encode and cheap to decode and so on. That just occurred to me. I hadn't looked at that.
Right. I hadn't seen any specific analysis on encode and decode performance, but that is a good question. Yeah. So offline container support, obviously, file-based workflows. It's not just about streaming, but we also want to be able to record it. Availability, ease of access, and this is actually a pretty interesting one, right? So there's a lot of ways that this can be affected. One way is that it's such a new codec that there's no implementation available, right? And we have a schedule where we want to launch IPMX, so it'd be great. We can wait around forever for whatever codec out there, but we need something that is reasonably available. Another way accessibility is affected is in licensing, right? So if there's RAND fees, that makes it different for like the open source community to use that particular codec, so that we would have to have a different codec that had those kind of RAND fees and things like that. So we don't get into those things, but we just at least mark them down as accessibility factors that people can consider. Some codecs have error resiliency built in. And the final one is an interesting one that you guys maybe have seen a couple of people demonstrate this, but multi-resolution support. So the idea is the ability to send out 3 streams that together are your 4K signal. If you want 1080p, you take the first 2, and if you want a thumbnail version of it, you take the first one. And that's way cooler than the proxy streams that are currently available from like NDI or SDVOE, in that your proxy stream now in this method is perfectly in sync, the exact same quality as your actual flow. The only difference is you're only getting a quarter size of it. So it's like a power of 2 multi-resolution support, and we're looking at that, or we're at least considering that, or are very intrigued by that idea. Another way to do it is your flow, everything in your flow is in one flow, but when you receive it, you only have to pick out the resolution that you want. So you're still taking the full bandwidth, but your processing side of it would be a lot less in that case. So we're looking at multi-resolution support as part of it too. So high compression codecs, just kind of grouping which codecs we've kind of gathered in. The high compression codecs we're considering are AVC, HEVC, and VVC. Also VP9 and AV1. In the high compression world, I have to say that the millions of PTZ cameras out there with H.264.5, supported are a big decision factor there, right? So if we can support that, then there's this whole market that can flash their firmware, and now we have lots and lots of IPMX devices out there. So high compression is a little bit interesting, but the market is going to be a big factor in that one. The mezzanine iframe compressions, we're looking at JPEG 2000, HTJ2K, JPEG XS, and SpeedHQ and VC6. So that'll be a very interesting one. That's probably the one that I'm expecting the most lively debate on. Obviously, JPEG XS, is a big consideration there. If I may just read some tea leaves here, I think it's much more about whether or not there will be another profile for a different mezzanine connection, because if we do pick something different for the baseline profile for Pro AV, almost certainly we will add the JPEG XS profile as well for interoperability with broadcast. So it's not that JPEG XS would not be in IPMX, it would just be whether or not it would be the main codec for the Pro AV industry. And then the interframe mezzanine codecs, as I mentioned earlier, with cold block caching with HTJ2 J2K, and then temporal differential encoding or coding, that JPEG XS, very similar technologies. They may even be the same, I don't know. But and then there's another codec out there called Calibri, which we are looking at, but it is not available as an open standard. So that one's a little bit different. That one's a very high-performing codec, so it is pretty interesting. As are HDJ2K and JPEG XS, but all three of those land under that interframe mezzanine codec. So we are evaluating that one as well. So there's other codecs that are out there that are part of what we're looking at. So ASpeed has their own kind of twist on JPEG 2000. There's JPEG XLS, but we recognize those, but these are the ones that we're kind of focused on. So I want to mention downstairs, you'll see a Nook down there, PC showing some videos under the banner of the codecs, and the different sequences that are on display down there are kind of listed out here. So these are the sequences that we've gathered. We have all of these things we have in uncompressed formats, and we're running them all through the different codecs and providing those samples to the group in Ames that will then kind of look at the quality samples and look at the performance data that we have. But you can see vector-based widgets, fine lines, those kinds of things, Windows and web browsing, small text, Windows OS, and then, of course, real-life video and CGI graphics as well. So this is the big spreadsheet that we have here. Again, iChart, but you can see, we have the different metrics on the side here, and then we have the different video formats that are the columns. And together, this is where we kind of check the boxes and we provide the data. So in addition to those sequences, we'll provide this spreadsheet that will have all the different measurement data in there as well. So kind of in closing, you can see that it's a collaborative effort, that there's a lot of thought that's gone into this. There's a tremendous amount of work just in getting those big, huge, multi-gigabyte uncompressed files on Dropbox drives that we can all send to and download and all that. So I'm really excited and just honored to be a part of such a great collaboration. And I think we also added the common use cases together as part of the group. We've gathered representative video sequences, and we're bringing all of that together to generate this report. So we're very excited about where we're at with this. We expect to be done very soon with it and bring this over to Ames, and then that'll be a lively topic for Ames to then digest and take that data away. So with that, I want to thank you very much for paying attention to Ben's presentation, and I've got my contact information up there if you guys have any questions, or I'll take any questions you have right now.
Please go ahead. Let's be sure that's turned on.